Again, don't attach any value judgment on that. One thing we know, yeah, I love you too. When yield to maturity is greater than coupon rate, bond value is less than face value. Hence, that's going to be a discount bond. And when YTM is less than the coupon rate, hence that's going to be a premium bond. You can think of yield to maturity as the market interest rate in a sense. For a straight bond, straight fixed coupon bond, the coupon rate, hence the coupon amount, is set at the time of the issue and it never changes. So when US Treasury issues a bond and it says coupon rate is 4%, assuming face value of 1,000, each coupon is going to be $20 and that's not going to change until it matures. Okay. We have things called floating rate bonds, but we're not going to talk about them at least for this chapter, where the coupon rate depends upon some sort of reference index rate, such as LIBOR or SOFR rates. In the markets, there is also something called, where is that? Current yield. Oops. Why did that happen? Control C. Oh, because it looks like I changed the face somehow. Current yield is conceptually similar to dividend yield for stocks. It basically says calculate the amount of coupon you're going to get over the next 12-month period or over a 12-month period divided by the value of the bond. But you should not use that for making any decisions. And our template automatically calculates that for you anyway. One thing you should know for discount bonds, coupon rate is less than current yield, which in turn is less than yield to maturity. For premium bonds, it's the other way around. YTM is less than current yield, which is less than coupon rate. Obviously, for par bonds, they are all equal to the same thing. And we can easily see that. Suppose yield to maturity is 6%, current yield is automatically 6% as well. But you shouldn't ever use current yield to compare any bonds. It's the yield to maturity that matters. Now, this automatically calculates the coupon amount and number of coupons. In fact, the bond value function, the bond value uses the PV function uh, to calculate the value. Now, calculating a bond value is easy, but carrying a bond in your portfolio has several risks. One of those risks is the interest rate risk. Okay, we're going to measure that as percentage change in bond value as a result of change in YTM. It's the wrong thing. If I increase yield to maturity, what's going to happen to the value of a bond? Is it going to go up or down? Remember, yield to maturity is the rate at which I discount the cash flows from the bond. So if it goes from 6% to 7%, what's going to happen to the value of the bond? Hmm? No, it will decrease. Remember, it's the rate at which I'm discounting things. So that means future payments are going to be worth less compared to what are they now. The issue is, what is, for example, why is this bond value 908? It shouldn't be. There's something wrong. Oh, I know. Let me save this. And reopen it. For some reason, Excel is slow today. Okay. I have a 30-year bond, which happens to be a par bond. So yield to maturity is 5%, and so is the coupon rate. If yield to maturity goes up to 6, what happened to the value of the bond? It went down. So in this case, it went down roughly, let me see, 14% or so. Okay, that's big. What if this was only a 5-year bond? If a bond is a par bond, independent of its maturity, its all value is always equal to face value. Obviously, this also goes down in value, but it didn't go down as much. It went down only about 4.3%. Okay.